Good morning, everybody. My name is Kat Cosgrove. I am an open source advocate at Dell. If you are not familiar with me and my career on the internet, I'm a Kubernetes maintainer. Unfortunately, I post a lot on Twitter, and my career launched due to explaining a problem with the deprecation of the Docker shim in Kubernetes. It got very dramatic very quickly, and it turned out I had a knack for explaining historically confusing and relatively complex problems in technology. So I started writing these series of talks. They are fun, they are informative. Many of you will have lived and worked through some of these changes, but may not be aware of what actually drove these changes and may not think much about how we got where we are. So let's talk about infrastructure as code. How does this click next? Hello? Oh. Yeah, it's going on the confidence monitor, but not back here. There we go. Thank you. Here, I'll move this mic down for you. So we have a lot of jargon in cloud technology, a significant amount of it in DevOps specifically. And while some of these concepts actually are relatively new, many of them are older than we think by a pretty wide margin. And also the definitions of these tools kind of tend to change over time. So sometimes we end up with somebody calling a tool some flashy new thing, and we think it's an entirely new class of tool. But what it actually is just a modern spin on a solution we already have for a problem we've had for decades. CI/CD is an example of this. We think of it as relatively new, as being like about as new as DevOps, as it's a core tenet of DevOps, but it predates DevOps by like 20 years. It's actually fairly old. So when you hear like big companies talking about getting into continuous delivery, we've had it. We've had it for 20 years. We just keep putting a new label on it. We keep putting a flashy new skin on it. Infrastructure as code is another example. It feels even newer. That one feels very shiny and new. But we have been programmatically defining machines and application environments also for decades, for quite a long time. What's actually going on here is that we are solving the same problems over and over and over again, just flavored by the circumstances and very, very specific shades of problems in which a pain point becomes impossible to ignore. It's just the same thing over and over again. So since we're talking about infrastructure as code specifically today, I'm going to define it for clarity because there is a little bit of argument on what infrastructure as code is that I'll get into later. So infrastructure as code means provisioning and managing computing resources through the use of machine-readable configuration files rather than by hand and on demand through the use of a UI. Seems simple enough, right? Clear. So usually this looks like something like YAML or JSON. Sometimes it also looks like code. This is Pulumi code, obviously. There are a ton of IAC products out there. There are open source tools of a variety of flavors. There are tools launched by specific cloud companies. Obviously, AWS has a couple, and a few like paid proprietary options. This gets you reproducibility in your infrastructure, which reduces your workload, but it also allows you much more visibility into what is going on with your infrastructure and your applications. Everybody should use some kind of tool like this. That's not to say that infrastructure as code does not have its downsides. It absolutely does. Reproducibility means reproducing bugs. So if you screw up in your original definition, suddenly your mistake is at scale 2, which can be funny or can be tragic, right? There are other things we do as software engineers to ensure that that's not actually a wide-ranging problem. In most cases, that's what canary deployments and feature flags and things like that are for, but that's another topic. You do also have to manage a potentially nasty problem called configuration drift, which is something nobody has really managed to solve yet. That's when the actual state of your infrastructure in the wild does not match whatever was defined with your IAC tool of choice. That could be your fault. It could be your tool's fault. It could be entirely out of your control. Nobody has managed to fix this or entirely prevent it, and there are entire talks on that topic. So the use of the word configuration in that definition is important, configuration file specifically. When somebody says infrastructure as code, your mind probably jumps to tools like Chef or Ansible if you've been in the industry for a while, or Terraform or Pulumi or CDK if you're used to something much newer. But its origins are way, way older than that. So it turns out that we have had problems managing and configuring fleets of machines since we first decided to start letting them talk to one another, pretty much. That's true whether we're talking about virtual machines or containers on a cloud provider or physical machines on a lab. This has just genuinely always been an issue since the 70s. Infrastructure as code has its roots in configuration management. And in fact, most configuration management tools, or tools we think of as strictly configuration management and not IAC, they do actually use an infrastructure as code approach. So I expect some folks to disagree with my assessment that these two tools are not quite as distinctly different as we think of them, and argue that they are two very different things. But that's fine. That is an argument I am totally willing to have off stage. So if we go all the way back to the dawn of modern computing, configuration management has been around since the 70s. And we thought about it as early as the 50s. There are some papers from very, very early on, around shortly after the ENIAC machine, the first computer, was built by the US military, talking about how do we manage automating some of the configuration of these machines and in fact fleets of them. Which is pretty cool. The computer was very rudimentary back then, and we were already thinking about how to configure them automatically in the future. But Make was released in 1976. This allowed a rudimentary form of configuration management. I'm saying rudimentary because it's not quite, but it was what we had. And then Pixie Boot in 1981, which was an early form of configuration management for whole machines. Make is really only good at an application level. Both of these tools are still in use today. Pixie Boot maybe less so. You see it more in industrial applications and academia, but it absolutely still exists. And many of you, if you're a programmer, have probably used Make. But they don't jump to mind when people think of configuration management. I see an argument for neither of these being configuration management. They maybe aren't. But the fact remains that we used these tools to automate configuration to the best of our abilities before we had more sophisticated tooling to do so. Oh, there we go. So this changed in 1993. CF Engine was built by a man named Mark Burgess. He spoke at KCD Oslo last year. If you ever get an opportunity to see him speak, you absolutely should. But he built CF Engine while he was a postdoc at the University of Oslo to solve his own problem. It was a side project that got out of control, which I'm sure many of us can relate to. So he was tasked with maintaining a large fleet of Unix workstations, which were all running different versions of Unix, and all had different problems, which required a lot of time-consuming and manual scripting and one-on-one user support to manage. It was not an ideal situation. He decided to abstract away the differences between all of these machines behind a domain-specific language. and that allowed him to significantly reduce the work involved in maintaining them. And that was CF Engine 1. It would later be followed by CF Engine 2 in 1998 and a complete rewrite for CF Engine 3 in 2008. But this was the actual earliest fully formed example of today's configuration management tools. Unless you're in your 50s, you've probably never professionally used CF Engine 1 and 2, but it was a game changer at the time. So why does infrastructure as code feel so new if configuration management is so old? Did we just not care about it much until now? Did the complexity that made this kind of thing so useful not exist outside of big multinationals and academia? No, but like basically every advancement in technology since the dawn of time, a need to handle greater and greater complexity at greater and greater scale is what drove us to change. So it's the cloud's fault. Many things are the cloud's fault. This one is the cloud's fault. So prior to the ubiquity of cloud computing, provisioning computing resources meant acquiring new physical infrastructure, whether that was going to buy stuff yourself or calling up your local data center to add another server onto your account. Utility computing, or the pay for what you use model, was not a thing yet. So scaling to infinity was not nearly as easy as it is today. And the only companies who really needed to scale that large were multinationals. And they could afford to spend money on excessive computing power that they were not necessarily going to use up. So this wasn't really a problem for the vast majority of companies. But the threshold for what constitutes at scale changes and grows over time as technologies evolve. That's why I don't really like the word. It's not specific. It doesn't mean anything outside of the context of when that moment you say the word. So in 2006, things changed because AWS released the first version of EC2. And rapidly, scalability was absolutely everybody's problem. Things got out of control very fast. EC2 and the popularity of utility computing made it easy for any small business to take up and pay for exactly the amount of computing resources they needed. But tools for managing that infrastructure had not really kept up. Things were getting more and more complex. Applications built for this environment were weirder, and we just simply didn't really have the tools for it. With infrastructure being created manually most of the time, because again, didn't really have the tools for it, growth and scalability were hampered. Provisioning and managing instructions for dozens of different environments by hand is really, really, really slow, and honestly not that reliable. How many of you have had to stand up infrastructure in the AWS console by hand without using the CLI? Yeah, it kind of sucks, doesn't it? It's not fun. It's not fun. It's hard to use, and they're all like that. That's not a uniquely AWS problem. It's just not the easiest thing to reproduce and manage. I find an excuse to say this in nearly every talk I give, but humans are not good at these kinds of repetitive tasks. We're not reliable for these kinds of repetitive tasks. We have bad days, or we forget to take our ADHD medication, or we come into work a little bit hungover, or something, and we make mistakes. But the computer's not going to make a mistake. It's going to do exactly what you told it to do, right? So these are not things that humans should be handling. It also introduces another problem. With no reproducible definition of what your infrastructure should look like, you have no idea what your infrastructure looks like. You don't know what it is relative to when it was defined. And you may not even know what it is supposed to look like if the person who set it up in the first place didn't document their process and then left the company. That sucks. That lack of visibility is a huge problem. So the problems brought on by that huge jump in complexity allowed by EC2, thanks Jeff, led to the introduction of a whole new class of tools for managing your infrastructure. This is the point in the history lesson where I'm talking about tools many of you have used. Some of you may have worked for these companies. We're nearing the end of the timeline. So in 2005, Puppet is released. Puppet relies on its own domain-specific language, just like CF Engine did, and it accomplished a lot of the same goals as CF Engine, but it drastically reduced the learning curve for those using it. CF Engine was notoriously hard to use. If you go back and look at the documentation for CF Engine 1, it is stressful. And in 2009, Chef is released and takes a slightly different approach. Unlike Puppet, it was built around using a Ruby domain-specific language. And while this means that you have access to a language that's pretty close to full-fledged Ruby, it's not exactly, but it's very close, it was less friendly for folks who came from an ops background and were used to writing configuration files, which at the time was everybody who did this job, right? It was just ops people. For a lot of people, the fight between these two tools, and it was like very much a rivalry, came down to, are you more comfortable writing something that looks like a configuration file, or are you more comfortable writing something that looks like a program, which is going to sound familiar in a bit. In 2012, an outlier came out. That was Ansible being released. 3 years later, it was acquired by Red Hat, which is fast, impressive, good for them. And like CF Engine and Puppet, it also used a domain-specific language. Unlike CF Engine, Puppet, and Chef, Ansible is agentless, so there's nothing installed on the target machine. It works through an SSH tunnel, which I think is very cool still. And this was my first configuration management tool. So these things dominated the market for years. They all still remain in use today to varying degrees, but we tend to think of them as configuration management tools. We don't tend to think of these things as infrastructure as code, even though they do some of the same things, many of the same things, as modern infrastructure as code tools, and they definitely can provision infrastructure for us in a code-like way. If you consider Terraform infrastructure as code, you have to consider Chef and Puppet, you know? So where is the line between these two definitions, and exactly how blurry is it? Honestly, I went hunting for an answer. I Googled it several times. I talked to people who've been in the industry much longer than me. I talked to engineers who founded some of these tools, and everybody had a different answer. There is not a clear answer. Tools for configuring whole machines and operating systems rather than applications do exist in classes of their own under the umbrella term configuration management. So instead, my opinion is this. Configuration management can and does exist on its own as some of the tools mentioned in this talk. Some of these absolutely are configuration management tools. However, it also exists as a part of the greater concept of infrastructure as code. And infrastructure as code wouldn't be what it is without configuration management. So I think it is accurate to say that infrastructure as code is just the natural evolution of configuration management. That's the new umbrella term. But how did we make that leap? Again, so the growing popularity of container technologies and Docker's introduction in 2013 causes complexity to become a problem once again. It allowed for much more sophisticated solutions and architectures, but causing whole new pain points with respect to scalability and irritating existing but previously ignorable pain points. Now, we did have containers before Docker for a very long time. Docker was by no means the first container solution. I've got a whole nother history talk on how old containers actually are, but they predate Docker significantly, and virtual machines have been a thing for decades. Those are very old, right? But Docker's relative ease of use, its lightweight, and especially the ability to easily share containers through a centralized repository meant it did a hockey stick. Like it very rapidly became super popular. This was also right around the time that the concept of developing applications as groups of microservices rather than as monoliths took off, which is obviously a design paradigm that Docker is very well suited to handling. Between Docker Compose and Docker files themselves, I think you can argue that Docker is itself like a self-contained infrastructure as code tool. It's obviously doing much more than that, and that's not really a hill I'm willing to die on, but it's worth thinking about the fact that it can provision and configure its own infrastructure and the application running in it. But the rapid adoption of applications built out of lots and lots of containers necessitated the creation of some kind of tool to manage those lots and lots of containers. Everybody in the room is probably familiar with these tools. The most widely used one is Kubernetes. We're the second largest open source project in the world now, which is a little bit scary, but we're doing great. But we've also got Docker Swarm and Nomad and Mesos. Kubernetes is notoriously complex. It comes with its own set of issues, obviously, but when you really need to scale something large and you need to do it dynamically, it is very hard to beat. I know a ton of people here and in general have widely varying opinions of Kubernetes, from Kubernetes is always the right choice, you should start with Kubernetes, build with like future growth in mind, and Kubernetes is always bad, it's a fad, it's a scam, you're going to regret this in 10 years. But that's not the conversation we're here to have. The fact remains that it did trigger a pretty significant change in the way we think of infrastructure. Fun aside, the logo has 7 spokes on it instead of 8, like a typical ship's wheel does, because the project was originally called Borg when it was internal to Google. Most people know that, but when they were open sourcing it, they originally wanted to call it 7 of 9, not Kubernetes. So they kept the reference to that in the 7 spokes on the wheel, which I think is cute. So the adoption of Kubernetes leads cloud providers to introduce a bunch of different ways to deploy it. Every major cloud provider has at least one way to handle Kubernetes workloads, although obviously GCP got out the gate with that first since they knew they were going to release it. Running Kubernetes on-prem also becomes a thing, and suddenly we need smarter tools for this work. In 2014, the same year Kubernetes is introduced, Terraform launches. Like most of its predecessors, it is capable of both provisioning infrastructure and configuration management. It uses a domain-specific language, but unlike its predecessors, it was designed to concern itself with the management of your entire infrastructure lifecycle. It's doing more work. And that lifecycle is now much more complicated and much more difficult to handle than it's ever been. Terraform becomes wildly popular as well, and it continues to be popular as a result of its very, very large community and its broad support for clouds and other tools. Most of you have probably used it directly, and I bet all of you have heard of it, especially after the license change drama and the OpenTofu hard fork and not getting donated to the CNCF earlier this year, and the whole thing has been messy. Everybody has heard of it. So Kubernetes matures. More and more things are built on top of it or extend it. AWS introduces a 17th way to deploy Kubernetes workloads. Corey Quinn schedules a weekly tweet to make a joke about that, because he's running out of material, I guess. And I build a whole career out of screeching about the deprecation of support for technologies mentioned in this very talk. And complexity becomes a problem again. So we've come a very long way so far, and each of these tools has strengths, usually reflected by the time and circumstances in which they were built. But ops teams and SREs are still left with an outsized responsibility for infrastructure and configuration management. And software engineers are given tools that use domain-specific languages that they don't know, and increasingly face situations that would benefit from the expressiveness of a programming language. We're supposed to be doing DevOps. Big companies are supposed to be undergoing like digital transformations to get closer to a DevOps ideal, a more equitable distribution of work between teams and a tearing down of silos. And we're doing something, again, that is not that, but we talk about it like it's closer to DevOps. So in 2017, Pulumi is released, and 2 years later, in 2019, AWS CDK releases. Both of these take a programming language approach. Both allow you to provision, configure, and maintain infrastructure in the languages most programmers are already familiar with. And this is repeating the chef versus puppet fight. That is all this is. It brings us pretty close to today as well. This is about where we are. There are a few like smaller fledgling tools that are trying to do something slightly different, slightly weird. We're all waiting to see if they manage to catch on, but this does bring us pretty close to today. I don't love that this is where we are. And I'll ramble about that in another couple of slides, but I want to note I don't like this tug of war we're doing. So each step along this tooling timeline has gotten us closer to the DevOps ideal, but we definitely are not there yet. I have skipped over some tools in this talk for simplicity's sake, like Nix and SaltStack. I do know that they exist. I do know that many of you use them. I do know that Nix is like really hot right now. But suffice it to say that the most detailed version of this timeline from Makefiles to full-fledged IAC is much longer than this talk, and it wouldn't all fit on this slide. There were a ton of little tools that came out in the 90s and the early 2000s through today that are trying to take a slightly different approach to this. But generally, like most things in computing, infrastructure as code is not that new. It's actually quite old. It is coming at the same problem over and over and over again, just flavored by the circumstances of the day, the specific technical problem we're having, the specific definition of scale that year. All we're doing is putting abstraction layers on abstraction layers on abstraction layers, which is true for basically every aspect of computing since we first nailed virtualized memory in the 60s. It does have its roots in concepts that have existed since the 1950s and technologies we've had since the early 90s. So it's old. Even if you've been around since Makefiles first allowed us to simplify configuring resources and applications, it's easy to take for granted how far we've come, but I don't think that we have come quite far enough. That tug of war between chef and puppet, and this tug of war we're now seeing between Terraform and CDK and Pulumi, is just that. It's not real progress. It is putting new branding on the same argument that we have been having since 2006. And that isn't progress, that isn't innovation. I don't believe that we're innovating in the infrastructure as code space until there is a solution that equally makes ops people and programming people happy. I don't believe that there is anyone out there today that has managed to put out a product that fills that gap. It's continuing to just be, well, we're developer focused, or, well, we're not forgetting about the sysadmins. And like, that's great, but that's not what DevOps is. We're cutting windows in the silos and throwing stuff through the windows, not tearing down the silos. And that's not ideal. So some person who is smarter than me and willing to found a startup, I'm not going to do it, needs to work on that. Some kind of abstraction layer that bridges that gap and brings real innovation to IAC, because I personally am tired of watching the same two companies with different hats on, fight over a job title for 20 years, you know? So I hope that you have enjoyed my walk down history lane and my rant. I hope you've learned something new from it, whether it was purely entertainment value or actually educational. And I hope it's given you something to think about. IAC is not unique in this like tug of war between two different approaches and like flip-flopping over what's popular decade after decade. Most aspects of computing do this, and once you start looking for it, you can't unsee it. So think about that the next time you're trying some fancy new tooling. Thank you.